हैं? देखते हैं कुछ ना कुछ तो कुछ Hello, now can you hear me? Hello. Yeah, okay. Okay, some actually mic issues are there. Due to that, hello. 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 Now everyone can hear me. Okay. Now the voice is clear. Okay. Okay. So in the last class we are doing the which one? Last class which date it was? Let me check. 11th. So 11th. Yeah, Markov model rules we are going through. So just I can go through the revision of that. So can you see the screen? So we are going. We have to study the hidden Markov model. But before hidden Markov model, we have to go through the hidden. Markov model. So Markov model, in the Markov model, we have to go through the three topics, that is the Markov process, Markov properties, and Markov chain. So what we have studied that in the Markov process, that a stochastic process in which distribution of future event only depends on the present state or the present event without knowing how present event has been achieved. Okay. So we have seen the property that the future state only depends upon the current state. It doesn't matter how the current state has been achieved. So this Markov property we have done. Then we have seen the examples. Then we have seen the Markov chain. Okay, so Markov chain means what? The state which are following the Markov property. Okay, the list of a state. Okay, oh sorry, the set of a state which is following the Markov property is called as Markov chain. So we have seen one example, first order Markov model, second order Markov model. Then we have seen the third order Markov model also. Then we have seen one example, that is sunny, rainy, and cloudy. We have solved this example, that given today weather is sunny, what is the probability that tomorrow is sunny and the day after tomorrow is sunny? We have solved this example. Then we have seen the probability also. Okay, till here we have completed that. Till here anyone has any doubt? The Markov model, किसी को कोई डाउट है? ठीक है, अब हम लोग पढ़ेंगे. Now we are going to see about the next topic, that is the hidden Markov model. Okay, so in the hidden Markov model, what we will see, first of all, try to understand it is working on the, whenever we are talking about the hidden Markov model, it is working on the sequential data. Sequential data and temporal data. Temporal data. Now you will ask that what is temporal data? That is the discrete time series data. Okay. So why it is useful? It is useful to compute a probability or distribution of event that can be observed. Okay, this is the main function of HMM. Now we will see the how the HMM model will be seen. Wait a minute. A structure of HMM. I think on the, so it is slide 11. So we can see this is one state, another state, This is another state. Okay. This is t. This is t plus 1. This is t minus 1. Now, this one is one state. This one is one state. This is one state. Okay. That is y1, y2, y3. We will come to that. Rishikesh, during the example, solve example, we will come to that part. Okay. Now you understand that temporal data is that discrete time series data. Okay. When we will solve the example, we will see that type of data. Okay. So this is x1, this is x2, this is x3. Okay. So this is the observable data. Observable state. We can observe this state, and this is the hidden state. Okay, we can go from this state to this state, and we can go from this state to this state. Okay, now what is the transition probability of this? Can anyone tell what is the transition probability? P is equal to t plus 1 is based on the current state. Okay, now we can see the examples. Now, a kid can be happy, a kid can be sad, and a kid can be sleeping. These are the three states, which is the time series data. From time to time, this is the time series data from time to time. That is, it may be happy, it may be sad, it may be sleeping. Okay, means when you observe the activity of a kid, with the time you can see it may be happy, it may be sad, it may be sleeping. Okay, Rishikesh, you understood that temporal data? Now, what happened? The kid become happy when he is playing. The kid is sad when it is crying. And a kid is silent means that he's sleeping. Okay. So let us imagine that a kid is in another room and you reside in another room. Now, when you see the kid is laughing, means that you assume that he is happy. When you heard the kid crying, means you assume that he is sad. And when you see that he's silent, means that you assume that he's sleeping. So this is the observed data. Based on the observed state, you can predict the hidden state. You got the point? Everyone, are you clear with this? Okay. So this is transition probability. It is from one hidden state to another hidden state. And this is the emission probability. Okay, are you clear with this? Now one more example I can tell you. Slide number 12. Let us see, we have a sentence, I book bus ticket. So this is one token, this is I is one token, book is one token, bus is one token, ticket is one token. Okay. Now, if I tell you to find the first part of a speech, you know that how many part of a speech are there? In English, how many part of a speech? I think 8 part of a speech is there. So I want that part of a speech tagging is there. So from the I, we can find this tagging. From book belong to which part, bus belong to which part of the speech, and ticket belong to which part of the speech. So this is known as hidden state. From the observed state, we have to find the hidden state. Understood? Everyone, are you clear with this? The concept that in the problem, we have given the hidden state, we have given the observed state. From the observed state, we can find the hidden state. Or from the hidden state, we can find the observed state. Now, let us see the machine learning model. Okay, so in the machine learning model, what we are doing? We are giving the training set to train the model. We have given the test set and it gives some value. It gives the prediction. Same like in the HMM model. When we talk about HMM models, what we will give? We will give the initial, we will give the transition state, and we will give the emission state. Emission matrix. We will come to that part. It will give you, and now we will give the observed state. It will give you the hidden state. When you will give the hidden state, it will give you the observed state. Okay. Are you clear with this? So component, HMM component. What are the HMM components are there? That we have to find. So we have to see that. First of all, that is the hidden state. Second one, that is the observed state, observable state. Third one, that is the transition probability or matrix. Fourth one, that is the emission probability or matrix. And fifth one, that is the initial probability. ये 5 चीज होनी चाहिए हिडन मार्कअप मॉडल के लिए. ये 5 चीज आपको दिया होगा क्वेश्चन में. यहाँ तक क्लियर है सबको? Everyone, are you clear with this? HMM component, hidden, observe. Everyone. Okay. Now we will come with the one solve example. We will solve one example. Then you will get a clear view about the hidden Markov model. Okay, so we will solve one example. So let us see that this is a sunny state. This is rainy state. And this is cloudy state. Now today is sunny. What is the probability that tomorrow is sunny? It is given. It is 0.8. Today is rainy, and what is the probability tomorrow is rainy? It is 0.6. Today is cloudy. The probability that tomorrow will be the cloudy, it is 0.2. Okay. Now, today is sunny and tomorrow will be rainy. What is the probability? It is 0.38. Sorry. It will be wrong. We have taken the so from sunny to rainy, the probability is 0.15. Now, can anyone tell what is the probability from sunny to cloudy? Anyone? Today is sunny and tomorrow will be sunny. The probability is 0.8. Today is sunny and tomorrow is rainy. It is 0.15. Today is sunny and tomorrow will be cloudy. What is the probability? See, sunny की जो एक्टिविटी है उसकी टोटल प्रोबेबिलिटी कितनी होगी? 1 ही होगी. It will be 1. So 0.8 and 0.15 already happened. So next what will be there? What is the value? It will be 0.05. Now same with the rainy. Rainy to cloudy, it is 0.02. Can anyone tell me what is the probability from rainy to sunny? Anyone? Anyone who can answer it? Yeah, it is 0.038. Okay, now cloudy to sunny. It is 0.05. Then, sorry, cloudy to rainy. And cloudy to sunny, it is 0.75. Are you clear with this diagram, everyone? ये diagram कैसे बनाया गया? Are you clear with this? This is known as transition state diagram. Transition state diagram. Okay, everyone. Arnav, are you clear with this? Arnav and Rishikesh. Rishikesh. Okay. Manu also. Okay. Now the next part is that if it is rainy, what is the probability of a person to wear the short coat and umbrella? So the probability of, if it is rainy, the probability of wearing a short is 0.05. Wearing a coat, the probability is it is how much it is? 0.4, no, 0.3. And probability of having the umbrella, it is 0.65. Same with the cloudy. So cloud, the having the short, it is 0 probability. Having the coat, it is the 0.5 probability, and having the umbrella, it is 0.5 probability. Same with the sunny also. Having the short, it is 0.6. Having the coat, it is 0.3, and having umbrella, it is 0.1. Okay. Now, initial probability is given of sunny 0.75, 0.2 rainy, and cloudy is 0.05. That is cloudy. Now, can anyone make the transition matrix? Transition matrix. कोई बना सकता है ट्रांजिशन मैट्रिक्स? देखो ट्रांजिशन मैट्रिक्स कैसे बनेगा. ये हो गया सनी रेनी क्लाउडी, सनी रेनी क्लाउडी. ये हो गया प्रेजेंट और ये हो गया फ्यूचर. So it is sunny to sunny, it is 0.8. Sunny to rainy, it is 0.15. And sunny to cloudy, it is 0.05. Rainy to sunny, you can see rainy to sunny, it is 0.38. it is 0.6, 0.02, 0.75, 0.2. Okay, emission matrix. So emission matrix you can see. Port umbrella. Sunny, rainy, and cloudy. It is 0.6, 0.3, 0.1, 0.05, 0.3, 0.65, 0, 0.5, 0.5. इसकी प्रोबेबिलिटी 1 होगी, 1 प्रोबेबिलिटी होगी, 1, 1 and 1. Everyone understood this? How to make the transition matrix seeing this transition diagram, and how to make the emission matrix seeing this diagram. Okay, everyone is clear? Now come to this part. Next is I will save this part. Now I have to open the 13 from the 14. You will understand this. Now you see this diagram. So we can see that we can take one condition, that is this is port, this is port, and this is umbrella. This is the observed state. Now can you tell me how many possibilities of the hidden state if this is the series of the observed state? Can anyone tell what is the probability, total number of possibilities of the hidden state if we have the three condition quote umbrella, and the hidden states are sunny, rainy, and umbrella? Can you tell me? Anyone who can tell that how many possibility states are there? So let M will be the total number of possibilities, and N will be the number of hidden state, and T will be the number of observation. So can you tell me in this diagram it is how much? It is 3. It is 3. So total M is equal to N to the power T is equal to 3 to the power 3 is equal to 27. Okay, 27 state will be there. Means what? It may be sunny, rainy. Another condition, it may be rainy, sunny. It may be cloudy. Like this, we have P1 to P27 possibilities. Okay. Now, everyone knows that what is the formula for the joint probability? Can anyone write the formulas for the joint probability? PA comma B is equal to P A bar B into PB. This is the joint probability. So if we tell that hidden state is theta and observed state is big O, then what is the joint probability between theta and big O? That is P big O comma theta is equal to P O theta into P theta. Okay. Now, out of 27 states, out of 27 states, we have taken one state. Means it is sunny, it is rainy, it is cloudy. And this is what? This is coat, this is coat, and this is umbrella. So we have to find the probability of this state, these possibilities. We have to find the probability of this possibilities. So let us take this one. So first we will solve this one. Okay, so observed state is the hidden state is of theta and this one. So if I ask you to solve this one, can anyone tell what is the formula for this? So we are going from coat comma sunny. So it will be the probability of coat sunny. We are moving from sunny to coat. Always remember into PS. Okay, this is only. Anyone has any confusion? यहाँ पे कोई कंफ्यूजन है? ये कैसे आया? मीन्स केवल हम इस ब्लॉक के लिए निकाल रहे हैं. अब टोटल ब्लॉक के लिए निकालेंगे. ये टोटल ब्लॉक के लिए निकालो. If you want to calculate this total block, so it will be big O comma theta is equal to big O theta into P theta, means that we can write it is coat, umbrella, sunny, rainy, cloudy. ओके, तो क्लाउड, ये जो कोट है ये सनी के साथ बनेगा, ये जो है रेनी के साथ बनेगा, ये अम्ब्रेला के साथ बनेगा. तो वी कैन राइट P ऑफ CS into P of CRA R into P of UCL into PSU into PRS into PCLRA. We can write here this one PCLR. Understood this one, how this came, or again I have to explain? Okay, Again, I am to explain. Wait. Wait, I will take new one. I told you that we have to find one possibility, that is sunny, rainy, and cloudy. And we have the observed state, coat, and this is what? This is umbrella. So this is the state, this is the state, this is the state, this belongs to this state, this belongs to this. Okay. Now we have to find for the whole these conditions. So we will start from this part. So when we will solve this one, means that it is P coat, comma, sunny. Its formula will be coat, sunny into P sunny. This will be only. Same way for this one. What is this one? For this one, what is the thing? P rainy, sorry, coat, we can write this one, coat, comma, rainy. What is the, can anyone tell? Coat, comma, rainy. What is the formula? Anyone who can say? Aymanyu, you can say what is the formula for the probability of coat, comma, rainy? Wrong. See, partially you are right. It is coat, rainy into probability of rainy and sunny. See, rainy has come from sunny ना. यहाँ पे मैंने PS क्यों लिखा था? क्योंकि इसका इनिशियल कोई नहीं था, इसके पहले कोई नहीं था, पर रेनी का पहले तो कोई सनी है ना. Are you getting my point? So that's why it is rainy due to what? Due to sunny. Understood? Now Arnav, you are right. Same way you can write with the probability of umbrella, comma, cloudy. Right? What is the formula? What is the formula? Now, Ayman, you write the formula for the umbrella, comma, cloudy. Arnav, you also, and others also. Please write the formula for the umbrella, comma, cloudy. Arnav, how the sunny has came? I already told you, you go through the Markov properties. Markov properties tells that the future state depends upon only the present state, not the past state. So why the cloud, for the cloudy, why the sunny will come? In the cloudy, it has nothing to do with the sunny. It has only to do with the rainy. So it is probability of umbrella, cloudy into probability of cloudy rainy. Okay, are you clear this? Are you clear with this? Now multiply this. So it is probability of coat comma sunny into probability of coat comma rainy into probability of umbrella comma cloudy. Now what is the coat comma sunny? It is this one. Now go to the transition matrix. Sunny to sorry, you can go this here. Sunny to coat, it is 0.3 and initial. What is the initial value of that is 0.75. So it is 0.75. So value will be 0.3 into 0.75. Now what is this one? Coat to rainy. You can see rainy to coat. Rainy to coat, it is 0.3. It is 0.3 and sunny to rainy. You can see from here. Now here you can see from sunny to rainy, it is 0.15. It is 0.15. So it is 0.3 into 0.15. Same like this one. Umbrella, cloudy to umbrella, it is 0.5, 0.5, and it is rainy to cloudy. Rainy to cloudy, it is 0.02. So this one is 0.5 into 0.02. So total, what is the total probability? We can calculate the total probability. Understood? Have you understood this? So this way we can calculate the probability. Yeah, it is 0.000100125. So by this way we can calculate the probability from P1 to P27. And the probability which has the max P1 to P27, that condition is the right hidden state for this observed state. Understood what I told? P1 से लेके P27 तक की प्रोबेबिलिटी हम निकाल लेंगे, जिसकी मैक्सिमम होगी वही हिडन स्टेट इस कंडीशन के लिए होगा. ओके एवरीवन, चलो अब आप एक प्रॉब्लम सॉल्व करो. एवरीवन विल सॉल्व वन प्रॉब्लम. I am giving one problem. It is hot. It is cold. Now, hot to hot, it is 0.7. Cold to cold, it is 0.6. From hot to cold, it is 0.3. And from cold to hot, it is 0.4. When it is cold, a person eat one ice cream. the probability is 0.5. It eat 2 ice cream, probability is 0.4. And when it eat 3 ice cream, the probability is 0.1. Same like when it is hot, probability of eating 1 ice cream is 0.2. When it is hot and it probability of eating 2 ice cream is 0.4 and 3 ice cream is 0.4. Initial of hot and cold is 0.8, it is hot, and 0.2, it is cold. Find first transition matrix, second emission matrix, third probability for following possibilities, for the following possibilities, that is hot, cold, hot. It eats 1 ice cream, it eats 3 ice cream, it eats 1 ice cream. Calculate it. Have you understood the question what I told? ये दिया हुआ है आपको transition state diagram. This is the transition state diagram. This is the initial. All the probabilities are given. You have to find the transition matrix, emission matrix, and probability for the following possibilities. Means क्या कि हॉट के दिन वो 1 आइसक्रीम खाए, कोल्ड के दिन वो 3 आइसक्रीम खाए और हॉट के दिन फिर से वो 1 आइसक्रीम खाए. इसकी प्रोबेबिलिटी क्या है? कैलकुलेट द वैल्यू. Anyone got the answer? Anyone who has calculated the answer? Anyone who got the answer or not? Arnav? Any other person? That is Ahimanyu? Okay. It is easy. Easy. It doesn't take too much time. You can tell the transition matrix. At least you can tell the transition matrix by the diagram. It is hot, 0.7, 0.3, okay, 0.4, 0.6, okay. Now it is hot to cold, 0.2, 0.4, 0.4, 0.5, 0.5, okay. Yeah, it is right. Arnav, it is right. Now, what is the probability? What is the probability for the following possibilities? That on the hot day he will eat only one ice cream. On the cold day he will eat three ice cream. On the hot day he will eat one ice cream. What is the probability for these conditions? Kindly try to understand this problem, because in the end term the question will be from this topic, numerical question. 0.00348. Aman has solved something. Aman, let me check. Okay, Aman also right, but what is the probability? Let me check the answer. Let me check what is there. So it is from hot to 1, it is 0.2. Let me check it. It is 0.2 into, then again after that it is cold to third. So it is 0.1. Then again it is from hot to 1. So hot to 1 it is 0.2. 0.2 into hot initial pH. pH is equal to 0.8 into 0.3 into 0.4. Yes, it is 0.00348. Right answer. Okay, so let me solve. Everyone has got this answer? Everyone. Answer for this question. It is 0.0000384. And the transition matrix, when you see the transition matrix, hot and cold, hot and cold. It is 0.7, 0.3, 0.6. And this is the emission matrix. Now the problem is that, now next problem you can see. Try to understand the problem in these solutions, that if we have an hidden state and we have the observed state is equal to 50. So you know we have to find the 10 to the power 50 probabilities, possibilities properties. Okay, that is huge computational will be needed. Huge computational cost will be there. To solve this problem, we have the another two techniques, that is the decoding problem and another one is the evaluation problem. Okay, means by decoding problem we will direct calculate the probability of the possible state. So this is done by the Viterbi algorithm. And this evaluation problem will be done by the forward and backward algorithm. So tomorrow we are going to see the decoding problem. Okay, are you clear with this? Everyone. So tomorrow we will see the both the problem. These slides I will upload in the drive. Okay, so kindly go through that. So with this, I am ending the today class. Okay, thank you.